Yeah. Good evening to all of you students. Today is the last session for this training program, AI 900 certification exam at Microsoft Azure AI Fundamentals certification exam. In the last class, so just I'm going to demonstrate how we use ML Studio Classic or Azure ML Designer to build a machine learning project. To work on a machine learning project, how we will use Azure Machine Learning Designer or ML Studio Classic. So ML Studio Classic, which provides the Azure Machine Learning Designer activities free of cost without any payment. Actually, Azure ML services, they are providing the services on the price based. They will charge some amount to run to utilize their services. To utilize their services, they will charge you. So you have to register the credit card. So they will provide you a few hours of computation hours. So you have to run all the programs, all the simulations, all the projects. You have to use that amount of time they have given. If the time is expired, then you have to again renew your subscription. So that is the case actually. But whereas ML Studio Classic will provide Microsoft Azure Machine Learning Designer service without any cost, but it is going to expire by 2024. After 2024, it will become a paid service again. It will completely remove and you go to the Azure Machine Learning Designer subscribed version. Hope you understand. So in this class, so once again I want to repeat, in this class, I'm going to demonstrate you how we will do a machine learning project without writing single line of code using Azure Machine Learning Designer in ML Studio Classic. So that thing I want to demonstrate how we will do this experiment, how we will do this project. So Azure Machine Learning Designer is one of the services offered by the Microsoft to do the machine learning project without writing any single line of code. It is completely drag and drop case. Drag and drop data sets and models, machine learning models and everything. No need to write anything. Just drag the data set, drag the machine learning model, and run the simulation and observe the prediction results. So how we will do all the things I'm trying to demonstrate you in this class, and this is the last class for you. Fine. So meanwhile, I'm requesting you, can you please turn on your camera for some time to take the snapshots? Later you can turn off. Can you please turn on camera for some time, please? Just only to take the snapshots. Can you please turn on your camera? Thank you. 7. Anyone else, please? 1059 1060 1214. Just only few seconds. That's it. 1214 1042. So fine. Yeah, thank you. So you can turn off if you want. Fine. So fine. Well, now we will work on. Students, are you able to see this ML Studio Classic classic version here? Are you able to see what I want to share you? You are able to see the slide ML Studio Classic.
Yes, sir.
Yeah, thank you. Thank you very much. So now, so you can build a machine learning project in ML Studio Classic, which provides Microsoft Azure Machine Learning Designer, where you no need to write a single line of code, only drag and drop all the modules, datasets, what are required on the canvas, and you can run the project. So how we will do it? So for that, so you can practice later. I will give it as an assignment for you. Do it and take a snapshot, upload it to the canvas. I will post that assignment later. Okay. So I will demonstrate how we will work on it. First of all, please log into ML Studio Classic portal using your Microsoft account. So if you want to use ML Studio Classic, you must have Microsoft account. If you don't have, you can create a Microsoft account at free of cost. Okay. So just I want to use this web link. So I already shared this PPT with you, right? Yeah. So this once you open this link, so you can see the page like this. Okay. Now actually it is asking for the sign in, but I already signed in already. So that's why it's directly coming like this. So otherwise, what is called? Yeah, already I have signed in. So that's why it's coming. Otherwise, you can get a screen like this. It will ask to sign in and click on sign in, and then it will go to the user ID password. Once you enter the user ID password, so it will coming like this. But anyhow, I will try to sign up. Now I want to use this link again. Sure. So you will get this page like this. See here, transition of the Azure Machine Learning before 31st October, August 2024. After 2024, this ML Studio Classic will retire. You can't use this one after 2024. So before that one, you can use it, you can build a project, whatever you want. But after it is not available, it becomes a paid service. Now click on sign in. So you have to log in. Yeah. Log in to your Microsoft account. So just to close it, just it is the information. ML Machine Learning Studio Classic will retire on 31st August 2024. So up to that you can use it. And after that you have to use the Azure Machine Learning service, where you require a subscription. You require a subscription. Right. So fine. Done. So now click on the blank experiment. Students, click on the blank experiment. I want to do a machine learning project. I want to demonstrate the machine learning project on ML Studio Classic. So click on the blank project, blank experiment. Now this is called a canvas. On the canvas, you can drag and drop the various modules, various datasets, what you require. So this is called canvas. So on the canvas, you can drag and drop all the things what are required. Okay. Now, which project I want to use here? I want to work on a project. The problem statement is I am going to predict the price of an automobile. I'm going to predict the price of an automobile based on some features. I'm going to predict the price of an automobile based on some features. Then already there are saved datasets are available, or you can build your own datasets also. So I want to use the saved dataset. So in the saved dataset, click on sample datasets, and you can see the automobile price dataset. So this is the automobile price dataset. So Studio Classic. So you have to upload your data initially, and once your data is available, just drag and drop the data onto the canvas. No need to write any code, just drag and drop the data on the canvas. Hope you understand. So first thing is data movement. So you have to drag the data set from the sample data sets and drag into the canvas. This is called a canvas environment. You have to drag it to this one. Hope you understand first step. I think if you have a college Microsoft account, you can use that one. Otherwise, you can create your personal account. You can use the personal account also. So you can use your, I think you are able to see the screen. So here you can see this, no Azure subscription, no credit card, no problem. So this is the free version as of now. Choose anonymous guest access and sign in with your work or school account or a Microsoft account, your personal Microsoft account also you can use, I think so. Okay. Hope you understand. And hope are you able to see the screen, right? Yeah. Now, once the data was dropped onto the canvas, next step is data processing operations you have to do. So first of all, visualize the data. First, visualize the data. So if you want to visualize the data, click on the module, click on the dataset module, and right click here, and click on the dataset, and you can see the visualize. So click on visualize. So once you click on the visualize, you can see what are the different features are there. Yeah. So these all are the various features which are there in the data set to predict the price of an automobile. So features are like a symbolic, normal losses, make, fuel type, aspiration, number of doors, body style, drive wheels, engine location, wheelbase, length, width, height, something different features are there. And finally, the target column is the price column. It is supervised learning. So you are going to predict the price. You are going to predict the price. So it's the target column and remaining all are the input features. Remaining all are the input features and last column is called the price column. So this is about the data. This is about the data. Hope you understand, right? So now what we have to do is first click on each feature. Click on each feature. Now I'm clicking on the feature symbolic. You can give the statistical information of the feature. It will give the statistical information of the feature. So there are a few number of samples are there, and what are the mean of the all the values, and what are the median value, what are the minimum value, what are the maximum value, all the information are available. And also, if there is any missing values are there, if there is any null values, any missing values are there, that also represented. So in the symbolic column, only 0 missing value, there is no missing values. But if you go to the normalized column, normalized feature, there are the 41 missing values are there. 41 missing values are there. So like that, if you click on any feature, it will provide its statistical information. For a make, there is no missing value. For a field type, there is no missing value. Why is not audible? I think this is the first time, right? Right. So you can click on various features and verify any missing values are there or not. So you have to observe. So I can show my second slide. So this is the information about the on the symbolic feature. There are 6 missing values are there. Normalized feature, 41 missing values are there. For the number of doors feature, horsepower feature, peak RPM feature, 2 missing values are there. For bore, stroke, and price feature, 4 missing values are there. And remaining all the features, there is no missing values. So now what I have to do? What you will do? Any suggestion? See, if you go to the normalized, feature, 41 missing values are there. And in the previous class, I suggested one of the treatment for the missing values, that is removal of the row. That means you have to remove the 41 rows. If you want to keep only one normalized losses column, if you want to keep normalized losses column in your data, because it has the 41 missing values, so you have to remove the 41 rows. That is not a right solution, right suggestion. So you are removing the 41 samples from the data. So then what you will do? Because there is 41 null values are there in your normalized column. So instead of removing the 41 rows, just remove this feature. Maybe it's not a much impact on your prediction. So remove this normalized loss now because it has the 41 columns, 41 null values are there. So don't remove symbolic number of rows like this because there are less number of missing values are there. But where in case of the normalized losses, there are 41 missing values are there. So that's why my suggestion is just remove this normalized loss column. Remove this normalized loss column. So how we will remove the normalized loss column? See. Fine. So now, if you want to select or remove a particular feature, then what you have to do is, here you can see one parameter called data transformation. So click on data transformation and click on manipulation and click on a module called select column in data. So drag and drop this module here. Hope you understand. Select column in data. Now connect these two nodes. Once you connect these nodes, click on the select columns in data set module and come to the right side. Here you can see the launch column selector. So click on launch column selector. Click on launch column selector. Now go to with rules. Go to with rules on the left side. There is a by name or with rules. Okay. Here you want to exclude normalized loss column, right? You want to exclude normalized loss column. That's why you can click here. Click on all columns. Among all columns, click on exclude. Click on exclude and select which column you want to exclude from the data. Select the feature, select the column which you want to exclude from the data. Which column you want to exclude? Anyone tell me through the chat box. Which feature you want to exclude? I want to exclude one feature. Which column we need to exclude from the existing data? Any suggestion, any idea? Yes, 1095, right? It is a normalized. Because why we have to remove that column? Thank you for your response 1095. So why we need to remove that column? Anyone? Yes, it contains the 41 empty cells, right? It contains the 41 empty cells. That's why I want to exclude that column from the data. Now here, click here and select the normalized, select the normalized losses, right? So exclude normalized loss column from your data because it has a more number of null values than the 41 null values. Once you select here, now you can see at the bottom, you can see the right mark. So tick mark, just enable the tick mark. That's it. Hope you understand till now. So in actually the original data, if you visualize the original data, if you visualize, you can see the normalized losses, right? Now I want to run this pipeline, run this project. So just here you can see the run and run the project. So if you get the tick mark, means your project is successful without any errors. Now tick mark is, so our simulation is perfect. So there is no errors. Now you can see here result in data set, visualize. You can't see the normalized losses here. Why? We are removing that one. We are excluding. See, symbolic and make, there is no normalized column, right? So because we are excluding from the data, we are excluding that from data. Fine. So what next we have to do? What we have to do next? See here, friends, because there is a 41 null values in the normal losses column, just I remove the normal losses column, but still there is some losses in the symbolic, number of doors, horsepower, peak RPM, bore, stroke, price, length, right? So what we have to do now? We have to treat the missing values. We have to treat the missing values. We have to deal with the missing values now. See, I'm not removing those features because number of null values are there. But you can't train a model with the data contains null values. So what is the null value treatment or missing value treatment? What do we have to do? What is the missing value treatment? So for that, for the missing value treatment, Again, in the data manipulation, there is a one module called clean missing data. So drag and drop this one. Clean missing data, drag and drop this column. Right. So that's the clean missing data. If you click on clean missing data, on the right side, you have the different operations. What are the different methods we use to clean the missing data? In the previous class also I explained. You can impute with the mean value, you can impute with the median value, or you can remove the row completely. So there are different methods. So on the cleaning mode, you can click here, you can see the different cleaning mode techniques. Different cleaning mode techniques. You can use any cleaning mode technique. I am using remove entire row. So wherever the null values are there, I want to remove the entire row. That's what I selected here. So clean missing data, the method I am using is remove entire row. If for against any feature, if there is any value is missing, then I will remove the complete row. So then the missing values will be removed automatically. Hope you understand. That is the method I am using to clean the missing data. To clean the missing data. Now, after connecting this clean missing data module onto the canvas, now run this project once again. Run. Done. So again, this is also tick mark. That means project successfully executed. Now, so if you hope you understand right here. So clean missing data is completed. Okay. So visualize. Yeah. So you can click on any feature. Symbolically, previously on the symbolic feature we had the 6 null values, but now null values are 0. So I will share that also. Otherwise, see for bore, stroke, price, there is a 4 null values: bore, stroke, and price features. Bore, stroke, and price features. Sorry. Bore, stroke, and price features. Where it is? You make bore. So missing values are 0. Previously 4 missing values are there. Stroke, missing values are 0. Previously the 4 missing values. So because we cleaned the data by removing the rows where the null values are exist, where the cells are empty. Okay. So that is the strategy we are following to remove the missing data. Now fine, you have a data without any missing information, plain data is available. Now I want to do feature selection. So feature selection means there is around more than 10 input features are there. There are more than 10. Sir, please once again how to remove null values. Yeah. So I will see previously we observed that in the data we have a different null values against each feature. Okay. So that we discussed already. Now what I want to do is already normalized losses feature already removed. This column is already removed. So not worry about this one. So for the remaining feature, symbolic number of dots, all the things, there is still empty cells are there. So if there is any empty cells are there, then what you have to do is, I think I already explained, but once again. So to deal with the missing data, so just what we have to do is on the manipulation, you can see a clean data module and drag and drop the clean data module here and collect it to this previous module. Now select the clean missing data module, and on the right side on the clean mode, you have the different operations. How you want to clean the data, whether you want to replace the empty cells with the mean value of the feature, or if you want to impute the empty cell with the median value, or if you want to replace the empty cell with the mode value, or if you want to remove the entire row. Now I am choosing this remove entire row strategy to deal with the missing data. So what it is doing is, just give me some time, my notebook is loading. So clean missing data module, how works? So here in our project, so we have some features, right? So we have some features like symboling, board, so finally our target column is price, right? So you have the different values for each feature in each row, in each sample. For each sample, you have the different values. Okay. Suppose if there is a one empty cell is there, this is the empty cell against your board feature. This is the empty cell. This is the missing value. Here the value is missed. No value is available. It is a completely empty cell. So the missing values are there. That means the no value is available here. The data which is required here is missing. In such case, if you are choosing the remove entire row option, if you are removing the entire row option, then what it will do is it will remove this entire row from the data. Once it is remove the entire row in the data, then this missing will not no more exist, right? That missing will no more exist. So that strategy, the clean missing data module perform. If you select the remove entire row approach from the drop-down list on the right side, hope you understand how the clean missing data works. Here I am selecting the remove entire row. Here I am selecting the remove entire row. So the entire rows where the null values or missing values or empty cells are available, those are completely removed. Once those are removed, so nothing, no missing data is available. Hope you understand right now. Now we have a data with some features where all the features are there is no empty cell. Every data is available against every feature. So till now it's fine now, right? Next. Now, if you see the data, again I want to visualize the data here. Clean the data set, visualize. I have more number of features. You can see more number of features like symboling, make, field type, aspiration, number of doors, and many input features are there to predict this price column. So from the data, you have to think for a demonstration purpose, I want to choose a few number of features instead of all the features. But in the real-time application, when you are working on your project, you have to think among all the data which is provided by the hospital, is all the features are required to predict the COVID. So yesterday I think explained feature selection, feature engineering. So let's assume you are working for MGM hospital. They gave the data. The data contains the date, time when the patient admitted, the patient ID, fever, cough, cold, everything, blah, blah, blah. Do you think all the features, all the columns are required in your data? No. So you can remove a particular feature. Yes, right? So here also, there are many number of features are there for the price prediction. I don't want to use all the features. So don't argue with me that why, sir, you are choosing these features, not these. Only for the demonstration purpose I am giving. Just only for the demonstration. So you have to apply your common sense, which features are required like that. Okay. So to remove some features, to keep only few features for the prediction of the automobile price. So again, I want you to select columns in the dataset module. Again, rather select columns in a dataset module. In the clean missing data, you have to use this. The clean data is available in the first node. The clean data is available in the first node. So connect the first node to the select dataset module. Okay. So again, in the select dataset module, click this select columns in a dataset module. Launch column selector. Now, which columns you want to select? Which columns you want to keep for your machine learning training? Which features you want to keep? Okay. So for only demonstration purpose, I want to use very few features. Only few features. I want to use wheelbase, select, length, and width and height. So only these features I want to keep in the data. So these are these only features I want to use in my data for the automobile price prediction. So just only demonstration again, only for the demonstration I am keeping, because if I keep all the features, so at the time of prediction I have to enter all the values. That is the reason why I am keeping less. Only 4 features I am using. Hope you understand. So I am selecting only these 4 features for the automobile price prediction. Still, any feature I have to add, I have to select. Anyone can interact with the chart box. So still, any feature is mandatory to select from the data. Any feature is mandatory, which I missed here. So here I am selecting wheelbase, length, width, height features from the existing data. These features are sufficient. Are there any mandatory feature I have to include in the selected columns? Here, I have to include in the selected column side. Any feature from the available features you have to keep. It's mandatory. Mandatory feature is there? Is there any mandatory feature that must be selected? Is there any such type of feature? Such type of column in the data? No. No. Only then not field type. No. No. So maybe you are worrying about only you are seeing this thing. Yeah. Now see. Now see. Closely observe these features. Which one? May required yes, 1032. You are right. It's the price. So price is the target column that must required, right? Price is the target column that must required. So that must required. That's the mandatory because it's a supervised learning process. You are going to predict the automobile price. So the target column must be required. That the price column is mandatory. Remaining features, which features you want to keep, that is based on how you understand your problem statement. Here only I'm keeping only 4 features because just for the demonstration purpose. Don't think that only these will impact the price. Only for the demonstration purpose, I'm taking that 4. Okay, but there is other factors also, other features have an impact on the automobile price prediction. For the demonstration purpose, only I'm keeping the 4 input features. Right, price 1032. Right, the price column. Now I'm collecting wheelbase, length, width, height, price columns, price features from the data. Yeah, I agree. I'm telling 1035. Maybe R4 also you can keep, may not, but price is mandatory because that is the target column. Okay, the features you may keep. You can keep the body size also. You can keep the fuel system. You can keep engine size, whatever it may be. But here I'm keeping only 4: wheelbase, length, width, and height, only for the demonstration. But price is mandatory. The price column is mandatory. Okay. Hope you understand 1035. So I'm not opposing you. You can't use the R cover. You can, but here for demonstration purpose, I'm using only 4 features. But the 5th feature, the price is mandatory. Price is mandatory. That's the target column because you are comparing with the price label. So once all these features are selected, again tick mark. Now run this project. Done. Okay. Now select this one. Results data set, visualize. So here you have, I think you have 5 features. That's it. Wheelbase, length, width, height, and price. Based on these 4 features, I'm going to predict the automobile price. Based on the wheelbase, based on the length of the automobile, based on the width of the automobile, based on the height of the automobile, I'm going to predict the price now. So price is the target column, right? Hope you understand it now. That. So this is the data. Now I have total 193 samples are there and 5 columns are there. 193 samples are there. In my data, I have 193 samples and 4 input features and 1 output feature. So students, anyone can respond. What are the input features here I have considered for the automobile price prediction? Input features. What are the input features I have considered here for the automobile price prediction? Any response? As wheelbase, height, width, and length something. And what about the yes? What about the target feature? What about the target? Yes, price. Perfect. Perfect. Now you are on the phase, right? Now data is ready. Now we have a data which contains 193 samples and 5 columns. Out of 5 columns, 5th column is the price column. There is the target column, and first 4 columns are the input features. Right? Now data is ready. So what is the next step? So now data is ready. So what you have to do now, if you want to work on the machine learning project, you have to split the data, right? Yes, agree. You have to split the data. So to split the data, there is a module here again. Under the data transformation, there is a sample and split module. So in that sample and split module, we have the split data module and drag and drop here, split data, and connect these two nodes. And if you select the split data, here a fraction of rows in the first. So this is the percentage of samples you want to use for the training and percent of samples you want to use for the testing. So here you have to tell how many number of samples you want to use for the training. So I want to keep here 0.7 means 70% of data I want to keep for the training purpose. Okay, I want to use for the training purpose 70%, and remaining 30% I want to use for the testing purpose. Okay, and moreover, how we split the data? Out of 193 samples, 70% of samples for the training and 30% of samples for the testing. How that will be divided? That will be divided. You can see randomized split randomly. Yes, agree. Who is this? Very good, Nana. Nice. I'm not able to see your roll number, but anyhow, nice. So you have to do 103, right? Perfect. So I'm keeping the 70%, right? So 70% of data for the training. That node 1 has the training data, node 2 has the testing data. So 70% of data available here, and remaining 30% data is available here. So you have to split the data, right? So using the split data module. Now again run this one. So you can do any projects with this Memory Studio Classic. Where it is? Stratified split. Where it is? I'm not sure. I'm not sure about that. But anyway, you asked me stratified split. Where it is here, na? Okay, here. I'm not sure. Anyhow, once again, I will verify and let you know. But mostly it will be keep it. Don't change any other parameters. You have to split the rows, not columns. Keep it as it is. Only thing you can change here is the 70%. Once again, I will go through this stratified split once again. But it's not a. You have to keep the randomized split actually. I'm not aware about stratified split well. I have to keep it false, and I'm going for the randomized split. Randomized split means those samples will be those samples will be selected randomly from the available data. That is the randomized split. Okay. Now here on the first node you have the training data. On the second node you have the test data. Now once the data split is over, what next step you have to do? Data split is over, training data is available, testing data is available. What may be the next one? Just any idea? Yes, perfect. 1032. Yeah, 1032 model selection. You have to select the model. So tell me, friends, this problem statement is a regression problem or a classification problem or a clustering problem? The problem what we are working currently is a regression problem or classification problem, right? Regression is a regression problem because you are predicting the automobile price. The price may be whatever it may be, the numerical number, any number that may be. So it's a regression problem. It is a regression problem. So if it is a regression problem, you have to choose the appropriate model. So go to machine learning section. Under the machine learning section, initialize model. And under the initialize model, you can go through many things are there. Just for demonstration purpose, I am working on only regression. Here you can see the regression problem. Because it's a regression problem, go to the regression. Here I want to use the linear regression model. Drag and drop that one. I want to use the linear regression model. If you have interest, you can try with the remaining also. Okay, it's a linear regression. I'm selecting the linear regression. Now data is ready, model is ready. Now we have to train this model on this data, right? So to train the model, again, you have a section called train. On that section, you have a train model module, drag and drop, right? So this train model expecting two inputs. One input is a machine learning model, and second input is a training data. So tell me, friends, which nodes I have to connect? Which nodes I have to connect? See here the train model. Here you can see the train model module. It expecting the two inputs. So one input is which model you want to train, and second input is expecting which data you want to use to train this model. So which nodes I have to connect? Yes, agree. So first I'm connecting the linear regression, because so it says that you have to train this linear regression model, and which, see, you said that from the split data. So from the split data again you have the two nodes. So which node you have to connect, the first node or second node? Yes, first node, because on the first node you have the training data. Yes, train node, that is first node. Perfect. Very good. That's it. But still there is error mark. Still there is error mark. So what is the error mark here is, on the train module, and select the launch column selector, you have to tell the target column. So train cheyalante a model teliyali kada, from the 5 column data you have to tell which is the target column. Then it understands, yes, this is the target column, remaining all are the input columns, input features. You have to tell that, yes. So you have to tell. So select price, move to this selected column and click on the tick mark. That's it. Now there is no red mark here. So you have to tell the train model module what is the target column. You have to tell. Then it understands. So among the data, we have the 5 columns. In the 5 columns, the price column is a target column, and remaining 4 are the input columns. It understands. Done. Train module. Very good. Now you have to run the project. So every time no need to run, but only at the demonstration I am running. Once you connect all the pipeline, you can run once at a time. That's enough. Perfect. So it's the tick mark means, so it's executed perfectly, no issues. Now when the training is over, now what you have to do? Test it. Agree? You have to test the model. Right? We have that is available. Once the training is over, you have to test the model. So test the model, you have a module called score model module. So where it is score module, score model module. Yeah, you can see here score under the machine learning, under the machine learning score. Here you have the score module. You can drag and drop the score module. So it is expecting score module means you want to test module. You want to test the model. Score module means you have to test the model. If you want to test the model, it's again expecting the two things. One thing is which model you want to test, and another thing on which data you want to test. It's expecting two inputs. Now tell me which column, which thing I have to connect to this input. From where we get the input from to here. Chat box. Interact. So and it's expecting two. Yes, agree. Very good. 1032, right? So one is from the train model. That's the model already trained. The train model you want to test it now, and split data. And the split data from the first point or second point. First node or second node. You have to pass the data here. Perfect. Second, because it has the test data. Second. That's it. Perfect. Perfect. Very good. That's it. Score model. Now again run the project. Okay. So here you can click in the score model, you can score data set, you can visualize. Yes. So these are the testing samples, and this is the actual price, and it's the score level predicted price. So your model for these 99.1, 186.6, 66.5, 56.1, your actual price is 15,510, but what the scoring is, what the predicting, your model is predicting is 16,085. Don't expect you will get the same answers. And moreover, you are using the very fundamental machine learning model, linear regression model. So you are getting some errors here. Hope you understand. So these are the predicted values, and these are the actual price. Actual price and these are predicted price on the testing data. Okay. Now, once the score is testing is over, you have to connect one more module that is called evolute module. Evolute model. The evolute model means it will give the information about the statistical analysis. Statistical analysis, like what are the different errors, and how much frequently that errors are appearing during the training testing process. Those things are available with the evolute model. Under the machine learning section, there is a evaluate. So evaluate model, drag and drop this one. So just connect to the first node here. So you have to connect to the first node. That's it. Again, run. Now you train your model, you test your model, and you are verifying the performance metrics information. Performance metrics. What is the performance of my model? So that information is available with the evaluate model here. You can click here. You can evaluate results, visualize. It will give the information about the errors of your model. So what is the mean absolute error, what is the mean square error, what is the relative error, what is the relative squared error. All the errors are available, and at the same time it will also provide the error histogram. Error histogram is each error how many times are coming. Here this error is coming for the 71 times, like that. How many times each errors are appearing during this process, that also is called error histogram. That's how we can evaluate the model. Hope you understand, right? So how we build the complete machine learning pipeline using the ML Studio Classic. Hope you understand. So, but you need a practice. Okay, just it's like a fun also. That's not a bigger task, and you have to explore more. You have to explore once you are working on any project, you have to explore more how to create the new data, contour, visualize. It is a regression problem. It is a regression problem. In the regression problem, there is no confusion matrix. If it is a binary classification problem, maybe you can visualize, but you have to explore once because it's a free of cost. So you can run the different. You can work with what's called any binary classification problem. Mostly, I think you are able to visualize the confusion matrix. But the problem should be a binary classification problem. But here we are working with the regression problem. That is the reason why it is showing the mean absolute error, like that type of errors only it is showing. For regression problem, the confusion matrix not exist actually. Regression problem, actually for the classification, binary classification problem, we require the confusion matrix and to build the what's called calculate the error. Is it right? 1032, okay? So you can take any binary classification problem like maybe something like I'm not maybe breast cancer, maybe it is a binary classification problem. I think so. Breast cancer diagnosis data. So try with breast cancer diagnosis data, but this time use some other binary classification model like decision tree or random forest or logistic regression model like that. You have to use, not linear regression model. So these are complete pipeline how we can run a machine learning project in a Classic, ML Studio Classic. It's a Azure machine learning designer. So you will get a questions like if you want to work on a machine learning project without single line of code, just drag and drop the various modules on the canvas, then which service is required? It is a Azure machine learning designer. You have to remove that last one. You have to remember it is a designer. We are designing. Okay. So you have to remember, you will get that type of questions in your practice exams in final examination. So now complete training and testing of your machine learning is finished. Now I want to create a web service. You can create a service also. If someone want to use your service, that also you can made using this ML Studio Classic. How you will do? So for that, so first you save this project. Yeah. Once you save the project, go to setup web service. It's not enabled. Now what we have to do is run again. Now what I'm doing is data collection, data operation, training the model, testing the model, evaluation of the model, all are finished. Now you have to deploy your model for a new web service for a prediction purpose by the third user, another user. So now click on setup web service, click on predictive web service, click on predictive web service recommended, predictive web service. So some boxes are hide, no required, not required all the information, right? Only input and output information is required. So this is the predictive web service. This is called predictive web service. Now what you have to further do? Small corrections you have to work on it. That one is, so this is the input coming from the user, end user. This is the input what the end user is giving, that is this module will catch that information. Okay. Now that information passed to your model. This is the model here. Scored model is there. Na? So this is the you have to concentrate on only three. One is your web input, another is the selected column. Maybe I think you are unable to see the screen. It's very, when I can't zoom also, I think. Okay, hope you understand. This is the first blue light now. So blue color. So this is the input. So this module will collect the inputs given by the user from the user interface. So this contains the input features. So those input features we have to pass it to the your model to predict, right? Now what I'm doing is I'm going to connect this case to this point, because your model will get the input from here, and this will collect the input entered by the user. I have some form. I will enter the values and I submit it. Those values are stored here, and those values are coming to this model. That is the input. Okay. And second thing, coming to this selected column, that's here selected. Okay. Yeah. Selected column here. Launch column selector. It is a production environment. So here, don't keep the price column. You have to remove the price column. Why? User will not enter the price column, price value. He will enter the four inputs. What is the wheelbase? What is the length? What is the width? What is the height? These values only he will enter. You are okay. So just remove this price column here in the production. Now again click on the tick mark. That's all. Only these two changes you have to do. Only these two changes you have to do. One is connect this module to this core model, and also remove the target column from the data. Target column from the data. This is a predictive environment, not training environment. This is a predictive environment. Once these two changes are completed, now go to deploy web service. You can see deploy web service. So click on deploy web service. Oh, first of all, you have to run. Sorry, run this one. Predictive environment. Run this. Running. So that's over. Now go to deploy web service. Here you can see deploy web service. Go to deploy web service. It will take some time. We are deploying this, right? So action is created, deploy web service. Now, if someone wants to use the web service, so click on test. So this is the web service URL. Web service URL. So it will give the user interface. Perfect. See, so it is your web service is asking the user. So what is the wheelbase? What is the length? What is the width? What is the height? So give the different values. So let's assume wheelbase is 25 and length is 35. So just randomly giving. I don't know what the values are inside. Just randomly giving, and it is around 30 and height is around 10. Let us assume, and test the request response. Just randomly I'm giving. So actually the values which are given may be not suitable. That's why I'm getting it. See, actually it is showing as a minus sign because the values which are giving the random values maybe that not exist actually for a wheelbase 25 length 30 like that. That's why. But if you give the proper values, so definitely you will get some answer. But here what is the value given? 65, 165. That is the predicted price, but giving the negative sign. Negative price under the month. But why I'm getting negative sign is because maybe I'm giving some different random values. Maybe we will check if there is any possibility to see that. The text is also gone. Okay, I'm not sure the data also. Okay, if you give the proper values, definitely you will get the proper price here. I'm giving the some values, random values. So because of reason we are getting that. So like that, you can create a web service where the third party, that means other end users can use it. They will enter their wheelbase value, their length value, width value, and height value. From that, they are able to predict the score of the able to predict the price of the automobile. Okay, hope you understand how we use the ML Studio Classic to use the Azure Machine Learning Designer service to build a machine learning project and also to build the web service. So this is all about the AI certification, AI 900 certification program. Of course, in our examinations, they will not ask to build a project using the ML Studio Classic, but only to make you some information about this one. I'm giving this a small demonstration, but many applications you can do. So try to work on it. It's very easy. No code is required. Even if you train a 10th class student, he can perform well with this ML Studio Classic. So this is all about ML Studio Classic and the machine learning designer. So this is the last class. By this class, I'm closing this training program, and the rest is in your hand. I already posted the PPT. I already posted the study material from the Microsoft, and I also posted the previous examinations questions. That means online resource that's called exam topic, where the previous online questions are available. So most of the questions are repeated. Okay, so first of all, I want to stop sharing.